So the complement of an event. Just anytime you see the word complement, you need to think of the word not. That's what a complement is. So in this example right here, I've defined evidently the event A right here to be getting a 6. That should not be the probability. It should just be how I'm defining the event. It's not the probability of event A. I'm just saying event A I'm defining let event A be getting a 6. And I'm assuming that this is I'm rolling a die. So if I'm rolling a die, the event that I've defined to be event A is getting a 6. The probability of getting a 6 is 1/6. Why? Because there's one outcome in event A, the 6, and there's 6 outcomes in the sample space. So the sample space for rolling a die, remember, is 1, 2, 3, 4, 5, 6. That's the sample space. So the 6 outcomes is what goes on bottom. The one outcome in the event that I'm talking about goes on top, and then if you divide 1 by 6, you get 1.6666666. So the complement of event A, again, I miswrote. So if event A is rolling a 6, the complement of A, and that's read, you would read it as, you would say the complement of A, but that's also called A prime. If event A is rolling a 6, then not rolling a 6 would be rolling a 1, a 2, a 3, a 4, or a 5. So if you wanted to find the probability of the complement of event A right here, then you would say, well, there's 5 outcomes in the complement of event A out of a total number of 6 outcomes in the sample space. So 5 out of 6 is 0.833. Now, you don't actually have to calculate the 0.833 this way, because all you ever have to do to calculate a complement is just say 1 minus the probability of the event. So we already found the probability of event A was 1.67, so the complement of event A is 1 minus 1.67. Those two things together should always involve the sum of 1, because it's all the possibilities. If A is rolling a 6 and an A prime, or the complement of A, is not rolling a 6, then when you put those two together, you should get everything that's in the sample space. So those two are always going to add together to give you a 1. So here's an example right here. Here's a frequency distribution. You see they've got classes. How many classes do we have right here? 1, 2, 3, 4, 5 classes. And there's 156 numbers inside this first class. There's 312, and I guess those are people, since these are ages. There's 312 people between the ages of 23 to 35. There's 254 people between the ages of 36 and 49. There's 195 people between the ages of 50 and 64. And there's 58 people above the age of 65. That's a total of 975 people. It says use the frequency distribution to find the probability of randomly selecting a user who is not 18 to 22. So find out how many are 18 to 22. Okay, so 18 to 22 is 156. So 156, that's the probability, that's the event that they are talking about right here. So the probability of 18 to 22 is 156 over a total of the total frequency, 975. And that means that the complement, the ones that are not 866, not 18 to 22, is going to be 1 minus 156. Well, that kind of makes sense. 975, if you take away 156 from it, you'll get all of this. And if you add those up, you'll see that it's 819. So 1 minus 156 over 975 is going to give you 819 over 975. And reduce that down, because we always report probabilities in reduced fractions or decimals. So reduce this down right here just to make it 156 divided by 975, and you get 0.16. And what happens if you put those two together? 0.16 plus 84, you get 1. And that's always going to be the case, because you're either 18 to 22 or you're not. And so that's the complement. So down here, so if the probability of E is 19 over 23, and I have no idea what this E is, it's just 19 over 23 is E, then how many are not E? Well, take 19 over 23 away from 1. I'm just doing some fraction work right here. Some of you are going, hey, fractions, then don't do it. Let the calculator do it. But you can rewrite 1 as the number 23 over 23, subtract it, and you get 4. So 23 is how many you have altogether. We're talking about 19 of them for some reason. So if we're talking about 19, then how many are we not talking about? Well, 19, 20, 21, 22, 23. That leaves 4 that we're not talking about. So 4 is the complement of E. And there I wrote the E right there, 4 out of 23. The probability of E is 0.55, then not E is going to be 0.45. Why? Because those two together, if 0.55 is E, then not E is 1 minus 0.55. Same thing right here. All right, so just remember, you're going to have that memorized. The complement is always 1 minus the event. Okay, the last thing I want to talk about, I don't have it on this piece of paper. For about 3 years now, I've been saying I'm going to add it, and I keep forgetting. So I'm going to go to the textbook. And the textbook doesn't even talk about this except in an extension problem. But this is going to be, I'm almost positive this is on your final as well. It's not complicated. However, if you don't listen right now and you don't pay attention, then you don't get it. I mean, because it's just something that you really have to understand. I mean, it's not hard. It's not a difficult concept. It is just that if you don't pay attention, it's not going to come instinctively. Okay, you just don't get it. Okay, so remember, the probability of any event is the number of outcomes in E divided by your sample space. How many outcomes you have in your sample space. Now let me say that in a little different word. This is comparing the part to the whole. Okay? Now, when we're talking about odds, that's something completely different. You can, first of all, they say, they use a colon right here to talk about it, and they read 2 to 3, but you can write it as a fraction. It's just not done very often. But here's the thing that you have to understand. So let's just look at this one right here. This says, the official rules of the contest state that the odds of winning a prize are 1 to 6. It says that the odds. Now here's how odds are different. The odds do not compare the part to the whole, the odds compare two parts. So this is the part that wins, and this is the part that loses. I don't ever know how to spell lose. Two S's. Win, lose. So it's not comparing, it doesn't give you a total, it doesn't give you a whole amount. So what this is saying, that if the odds of winning a prize are 1 to 6, then one game is going to be a winner, 6 games are going to be a loser. That's a total of 7 games. And why is that way? Because that's the way odds are. That's how odds are defined. The number of successful outcomes compared to unsuccessful, wins to losses. Whereas this up here is comparing, like if we use the same words, we would say this is kind of the same thing. The probability is comparing success to the total number of games. Not success to failure, but success to the total. Or probability could be failure to total, but probability always involves the total. Odds does not. Odds does success to failure. So then it says, is the claim 1 in 6 game pieces win correct? The answer is no. Why? Because if your odds are 1 to 6, that means you win 1 game, you lose 6. That's a total of 7 games. If you want to state it like this, it should say 1 in 7 game pieces wins a prize. So let's do another one. The probability of winning an instant prize game is 1 out of 10. So the probability of winning is 1 out of 10. Now, based on the definition of probability, that means 1 represents a win, 10 represents my total number of games. Because that's how probability is. The number that's in the event, that's 1 win out of your total sample space. So 10 games is my total sample space. That's how probability is defined. The odds of winning a different instant game prize are 1 to 10. So if the odds are 1 to 10, this is wins, this is losses. So that is a total of 11 games. You want the best chances of winning. Which game would you play? We'll change that into a decimal. This 1 divided by 10 is 0.1. Here you would do 1 divided by 11, and 1 divided by 11 is going to be a smaller number because you've got smaller pieces. That's going to be 0.09. So what is your best chances of winning? This one, because 0.1 is a little bit bigger than 0.09. The odds of, okay, pay attention, the odds, that means it happened. You can call it win or loss, or you can say it happened, it didn't happen. These are also complements of each other, okay, because together they make up the total. So this is event E, this is not event E. Find the probability that the event will occur. So wins is 4 out of 9. The probability that the event will not occur, that's losses out of 9. A card picked at random from a standard deck of 52 playing cards finds the odds that is a spade. So odds means you're going to compare the fact that it's a spade to the fact that it's not a spade. Again, you're comparing an event to its complement, not an event to the total sample space. So how many spades are there? 13. How many cards are not spades? 52 minus 13. 39. So that's the odds. And then you would reduce that if you can. 13 and 39, I think it's 1 in 3. 13 divided by 39, you'd reduce that. Yeah, it's 1/3. So you wouldn't leave it like this because 13 can reduce and 39 can reduce. So that really becomes 1 in 3. A card is picked at random from a standard deck of 52 cards. Find the odds that it's not a spade. A card is picked at random from, find the odds that it is a spade. Okay, so the fact that it is not a spade would be the other way around. 39 are not spades compared to the ones that are spades. So this is the odds here are 1 to 3. Over here, the odds are 3 to 1. This is bigger odds than this one right here. 3 chances of getting not a spade compared to 1 chance of getting a spade. It just depends on what you want to happen, whether it's better or worse. Okay, but the thing that this question right here, if you understand this question, then you're okay. This question right here is exactly what you're going to have to do on your homework, on test number 2, and on the final. So be sure that you understand question 93. If not, ask me and I don't have a different explanation, so I'll just explain it to you again because I'm just going to keep saying, using the same type of examples because that's exactly what it is. Like this is, I usually talk about going to a basketball game. Okay, so the odds of winning the basketball game, that means that we've won. This is like a win-lose schedule. We've won 4 and we've lost 5. But when you figure out the probability of winning based on that, you do the number of wins compared to how many games you played. Well, if you've won 4 games and you lost 5 games, that means you've played 9 games. So when you figure probability, you have to do the number of wins. 4 would go on top out of the total number of games you played, that would go on bottom. That's kind of the way I do it. So this is like a win-loss record. Odds are kind of like a win-loss record. Your number of wins compared to your number of losses. But when you do probability, that's the number of wins out of the total number of games that you've played. Or the probability that you will lose is the number of losses that you've had over the total number of games that you've played. So that's the big difference between odds and probability. All right, I'm done talking.